Okay. All right, great. Okay, so we're recording now. I'll start with Brightspace, just kind of the discussion. Remember, there will be a homework assignment about this. Currently, I have a few problems, but wait until tomorrow to see if I added some new problem. I think I was going to do the spaghettify a matrix, so I might add that. And then today I'll just do examples of NumPy. It should conclude NumPy as far as the review. And then on next week, when we start week 3, we'll get into our first like machine learning, taking a data set and playing with that. So we'll be using the Weka toolkit, which is a very straightforward toolkit. And we should be able to learn how to master it basically in 1 week. And you can do your quick data processing or data, visualization, analysis, quick analysis with the Weka toolkit. So it's very nice, as you will see. If you haven't done so already, you can go ahead and install it on your laptops. Spelled W-E-K-A. I think provided the link somewhere. All right, so make sure you install it and have it available. And it's a totally 100% GUI interface. So it's a good place to start with machine learning. Yeah, so, but today we're doing NumPy problems. I did get the Scholar environment set up, and I've added your accounts. I just haven't had time to give you the link, all right, to get in there, but you should be able to get in there, okay? All right, so, but we'll talk about, we don't need it right now, so we'll talk about that later. All right, so let's go ahead and click on content here. Kind of get situated. So we have covered this module already, and you had a homework assignment, which by the way is due tonight, but you have until Saturday, I think, or so, where it will close fully. So if you submit today or before Saturday, you won't lose any points. If you don't submit by Saturday, though, it will close, and that's it. Okay, so please don't forget to do that. All right, so now we are looking at module number 2. This is the module. I provided all these links. I think I've covered on Tuesday's class about 30 to 40% of all these problems. And today I'll do a few that I think are important. So in some of these cases, there's like, for one particular topic, there's 2-3 variations of it. So maybe I'm just doing one, and then I'll leave the other 2 for you guys to complete. Okay, so we'll cover that today. We'll finish that up. Now, this is the document that I currently have as far as the problems. I know I want to add, as I said, one more problem. So just please, you can start with these. I'm not going to modify these necessarily. I may change the dimensions a little bit. So as I said, wait until Friday, but they will be similar. So if you look, problem 1, create 2 matrices, A of size 3 by 4 and B of size 5 by 4, and merge them into one single one of size 8 by 4. Okay, so that's one of the problems. Number 2, create a vector of size 10 and call it A. Now copy it into a new vector and call it B. There's an example for that in the link. But make the value in B shifted by 1 index to the right from the value in A. So I think we did something similar to this. Use 0 to ensure that both have the same length. So for example, you have 3527, and then here you have 0352. Okay, so that's the second problem. I'll go over these again. And then number 3, create a matrix X and a mask matrix M. Add or multiply X with M. So X operation M, which would be equal to new X. So that only the values below the diagonal appear in the new matrix new X. And this is the example. You can see it here. You have the whole matrix. You got to figure out the mask with the operation, and then the results should look like that. Okay, so these are the 3 problems currently that I have. And as I said, I'll review these again a little bit plus add maybe 1 or 2 more. Is this clear, guys? And so you have to obviously implement this in Numpy, create the matrices, perform the operations, and so on. Okay, yeah, go ahead.
And then submit the Jupyter Notebook script.
Don't submit the Jupyter. Instead, create a PDF of it. So either export it to PDF or print the PDF. It's literally the same thing, and I can tell everything. Does that make sense?
Yep.
So please don't submit the, you can add the Jupyter in there, but definitely put a PDF or a report. Any other questions? Okay, so as I said, this gives you an idea of the problems. Just kind of went quickly through these, but I'll look at them again and then add maybe 1 or 2. I'm thinking of that. Something very common is to take a matrix and spaghettify it, right? So maybe I'll give you a black and white one or a color one or something like that. We'll take it. Maybe a broadcasting problem could be answered. So wait for 5 problems by tomorrow. Okay? And then you'll have a week to work on it. Any questions of what needs to be done? All right, great. So did everyone sign in, guys? Everyone sign in? Nope. Thanks. All right, so now that we've talked about the word problems, let's go back to the link, which was this one, right? Numpy examples. I do have some notes on these, like explain. Oh, yeah, thank you. I do have some notes of these, how they work, but I just haven't loaded that. So I currently only have the code examples. So we are going to continue. We're going to need to bring up our environment. So the Numpy environment that we were using. So I think we've done, just going to do a review, I guess, until we get to the point where we were. So I know we did line space. We've done random. So we went over that. The identity matrix, I just kind of left for you guys to work on. We've done shapes, right? So we did indexing. I'm pretty sure we did indexing. So we've covered that. Slicing, remember I said that's really important. So definitely go through slicing examples. Those are really important. Shifting, we did this example, I'm pretty sure. We did extracting a row and extracting a column. So I know we did that on Tuesday. And there's the example that talks about copying. So I'm going to let you guys read through that one. And I think this is where we left off. Yeah, so we're going to start here at concatenate, basically, okay? So yeah, okay, so all right, so let's start with today. We're just going to do the same thing we did on Tuesday. I'm calling this review of NumPy operations, right? So things that, are going to be critical once we start getting into the algorithm so we can perform these operations for manipulating the data. I already gave you the example where I gave you one initial data matrix and you slice the X and the Y out, right? So those are important elements. So let's go ahead and start the Jupyter Notebook. Anaconda prompt. Okay, so dir. I think it's ITS 365 2024. dir and Numpy examples 2024. So this is what we were going through. Remember, then you've got your conda environment list, correct? So you look for the environment. I want to say is that 365 one. Conda activate I 37 ITS 365. Okay. All right, so we're in the environment now, so we can proceed to start the Jupyter Notebook. All right, so that should be it. So let's take a look. We're going to start the program here. Okay, all right. So we have our NumPy examples that we've done. All right, I'm just going to go through this really quickly from beginning to end, make sure everything is loaded. Okay, so we've got all that. Shape. Okay, so that's, yeah, new axis, right? So we've talked about that one. All right, so the next topic that we're going to look at is concatenation. So concatenate. Okay, I'm going to do markdown cell, and there we have it. Okay, so another important NumPy array technique is concatenation. This is used a lot in natural language processing, for instance, which basically mean, you know, in NLP, you have models like transformers that get an input of a tensor basically and produce another tensor, but then that tensor needs to be added to the previous tensor. You see, so when you're generating language, you're generating tensors. And you have one tensor, and then you generate a new piece to it, so it needs to get added, right? And then that becomes the tensor, and then it generates another little piece, and that gets added. Do you see that? You're not going to add words because that would be too slow. Instead, you're doing everything at the tensor level. Tensors are, you know, NumPy arrays, right? So it's basically just matrices and vectors, okay? And the general term is tensor, regardless of what language you're in, whether it's NumPy, PyTorch, or tensor. All right, so this is common there. So we are going to look at how to concatenate basically vectors in this case. So I'm going to create a vector A. I'm going to say it's an np.array, right? np.array. And it's going to be 1, 2, 3, 4. Okay, and then I'm going to have another one. I'm going to call it B, and that's going to be np.array, right? Okay, and this is going to be, let's say 5, 6, 7, 8. 5, 6, 7, right? So I have there my two NumPy arrays now, and I want to make them into a single one. So I have print A, print B. So if I run this, you know, I've got my two NumPy vectors in this case. Now I'm going to want to concatenate them. So it's straightforward. Most, you know, PyTorch and all of them have a concatenate function basically. So we can create a variable np.concat. Okay, and then you just specify the tensors that you wish to concatenate. So in this case, we're going to say A, comma, B. All right, so now if we print AB, right? you can see that we've concatenated, but we've concatenated at a tensor level or a matrix or vector level. Okay. Right, so this is an example. You can do this for three things. Like if you had a third one here, let's just copy this one. Actually. Let's call it C. And this would be 1, 1, 1, 1, something like that. And then now we could concatenate ABC basically. So I'm going to do this, right? And you can see it's basically concatenated. So you can concatenate several. It's one of the tools that we have available. Now we can also concatenate matrices, right? So we want to do two matrices. And here, because matrices have multiple dimensions, we can think of how we're going to concatenate them, basically vertically or horizontally, right? So we're going to go ahead and create a matrix example. I'm going to add a few more cells here. Okay, I'm going to hit save. Okay, so I'm going to do M1. Okay, and I probably have a matrix somewhere in here, so I don't want to have to type it up here. I'm going to borrow this one. Okay, so I'm going to do M1. Okay, I want this to be 3 by 3. So let's do that, 3 by 3. So then I can just simply get rid of this column. That, right? So I have that matrix. That is M1, and then I'm going to create a second matrix, M2. I'm going to do M2 here. I'm going to change these values to 1, 1, 1, 1, 1, 1, just any number so that they're different. 101, 1. Okay, so now that we have these, we can just also use the same concatenate function. So let's run that cell. And I'm going to do here M1, M2, and it's gonna be NP dot concatenate. I'm gonna specify a list basically of items. So M1 comma M2. Okay. And then here I have the option that's really nice. These constructs like NumPy, PyTorch, they're very verbose, right? And that means you put in a lot of pieces of information in there. So in here, we can say that we want the axis to be 0, for instance. So this is what allows us to store things either vertically or horizontally. So now that I've done this, let's go ahead and print M1, M2. Right, so we run that. And you can see it stacked them. So row 1, 2, 3, 5, 6, 7, 9, 10, 11, and then followed by 11, 21, 31, then row 51, 61, 71, and then 91, 101, and 111. Okay. Any questions? So that's an example of that. As you can see, we can probably change that axis to be 1. Just to see the effect. And you can see now it's in the other direction. So now it did 1, 2, 1, 5, 9, 2, 6, 10, 3, 7, 11, followed by 11, 51, 91, 21, 61, 101, 31, 71, 111. When you do these kinds of operations, sometimes it makes sense to do these. But I always suggest you do a small example first. Like you'll see a lot of the time when I write scripts, I'll work the code, and then at the very bottom, it'll say working out the math. And I just do like a small example of these things just to make sure that the values are like I want them, that's a good practice so that don't just think that even if you're very smart, always make sure that you double check. because you can get confused really easily. Okay. So we start with these ideas. So we were able to concatenate our matrix. There are there's always different approaches to doing things. So another approach is to use the functions vstack and hstack, which basically means vertical stack and horizontal stack. So we can use the same data, and instead I'm just going to use vstack here. So I'm going to take the M1 and M2, and I'm going to say, I'm going to call this one N, and I'm going to take NP dot, but now instead of the concatenate, I'm just going to use vstack, right? And a similar approach, you take in the list, and it's going to be M1 comma M2, right? And then we can print N. So if we go ahead and run that, you can see it stacking them vertically. And then we can repeat for horizontally. Just change this one to H stack. Similar idea. You can see. See, they're basically the same thing. So there's, but sometimes these functions may have additional little flags or parameters in there that really do help you out. All right, so far we've been playing with matrices and vectors, NumPy arrays, basically. But obviously, having data means that you want to do math with it, right? So you're going to do some kind of math calculation. So you're going to do some something. So here I'm just going to do some examples of the math functions that we have available in NumPy. As you can see, I've already in one of the problems asked you to use some math, right? To do an operation, to obtain a result. You have a something and something else, and you're going to get an output. That's a very common thing in machine learning, right? You have a X times something, you get a Y. That's basically, if I had to summarize all of machine learning into one sentence, it would be that. You have an input times something equals an output. That's it. All right. And so that's kind of the approach. So let's look at some math operations that we can do. And then these math operations start to get more complex as we look at broadcasting and, matrix multiplications in the sense of like linear algebra or element-wise operations, etc. So there's different ways of thinking about things, right? And so we gotta be aware of those items. So here, I'm gonna create a vector. So I'm gonna say np dot array square bracket and 1, 2, 3, 4. So I just have a vector with 4 values, 1, 2, 3, 4. We can print x. Okay, so we have 1, 2, 3, 4. Now we're going to do some math operations. So let's add 10 to x. But remember, we're used to adding things to one variable. Right now, your mind has to start to shift into this idea that we want to do operations on multiple values at the same time. So on the whole matrix, on a whole vector, a slice of it, etc. Right? Matrix multiplications. So it starts to get in. And then there's a lot of tricks that this provides, such as broadcasting, to make things even faster and easier. Because remember, as I've said many times, all these libraries, NumPy, PyTorch, and TensorFlow, are actually binaries in C, C++. So they run very efficiently, but we just program in Python. So let's go ahead and add. So we're going to do x plus 10. Okay. So what's the effect there? Notice that just by doing that operation, applying that plus 10 to the vector, all elements in that vector are now you've added 10 to each one. So 1 plus 10 is 11, 2 plus 10 is 12, 3 plus 10 is 13, and 4 plus 10 is 14. You see that? So this is it. right there. This is what we're doing quickly, right? You know, not sequentially, but in one shot. Because if we gave this to the GPU, this is what we want the GPU to do, right? Not give it 11 plus 10 and 12, you know, and that takes 4 seconds. In an exaggerated case, we want it to take 1 second in the GPU, which is the GPU is really good at that. Okay. All right. So now and this the rest is they're very repetitive. So I'll do like x minus 10. So these should be negative values. See them there, right? So all at once. We want to do x times 10. Okay, so we perform that operation. You can see it's 10, 20, 30, 40. Okay. We can divide by 2. I'm going to do x divided by 2. Okay, and you can see those are the values. 2 divided by 2 is 1, and so on. Questions so far, guys? Questions? Nope. All right. We can make operations such as minus x. Right? You can see it just makes everything negative, all elements. If we want, let's see. Let's try x to the 2. Right? What is x? I forget. All right, so 1 to the 2 is 1. 2 to the 2 is 4. 3 to the 2 is 9. 4 to the 2 is 16. Do you agree? All right, so you can see we apply all these operations to the whole vector, right? Okay, so that kind of illustrates how this works. So you guys can see the example here. Any questions? All right. So then you can do a few more. Now let's do some trigonometry. So here, we also have trigonometric functions like sines and cosines in Numpy and in all libraries, right? Some of the algorithms actually use this for some of the steps. So let's try one. Now we're going to think of how to generate sine values. So let's do angles equal np dot linspace, right? And then we're going to say 0, 4, 10. Let's print angles just so we see the values. You always kind of want to see the shapes, the values, things like that. So we have there some values. Now we can run this vector of values through a function, right? So what we want to do here is I'm going to say, I want to run these angles and I'm going to generate sine vals. Let's call it. Okay. So I'm going to do numpy np dot sine of the whole set of values. Okay. Like we are actually going to give it all those angles. How many did we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? From 0 to 4. Okay. And then I'm going to print sine vals. You guys see that? Okay. Oh, angles. Right? Yeah. Okay. So they both have the same size, correct? So for each one of the inputs, we got an output. We were able to run the entire vector through a function to generate the results, right? Instead of you having to do a for loop and always applying the function and capturing, we're able to do that. So I believe at the beginning we did matplotlib, didn't we? Yeah, so we should have PLT in here. So then let's try to do plot this, right? So we want to plot these values. So how would this work? Thinking here. So PLT dot, so this is a good example. This might be a homework problem. PLT has scatter, histogram, and I think plot is another one, right? And so these are ways of plotting data. So let's just try plotting this. May not even make sense, but let's try. So it would be angles, sine, vowels, and it might complain about something. Okay. Okay. So from 0 to 4, we have some values, and then we have the equivalent value of it, right? And we can see that there is a pattern, right? And by the way, it looks very much like a sine. Do you guys understand? Questions? Yeah, go ahead.
What library is plot?
Oh yeah, so PLT, right, is what I was said. So I went to the, if you remember on Tuesday, I actually added this library, matplotlib.pyplot. So this is kind of like a commercial, but this is the visualization course that we offer, the 400 level class by Professor Gurjin. It's really all about this data visualization. So, I mean, in this class, every now and then I'll use this, but in general, I'm not, you know, in a very dedicated way, I'm not showing you how to use this. But anyway, this is an example. Here it is. And I will use these throughout the semester of just plotting your data, looking at it, and seeing what you have. So it goes, so the sign values go 0, 4, 7, 7, 9, 7, 9, 7, 7, 9, 4, 5, 0, 3. So they go down, basically, up and down, sorry. They're going up and down in a pattern. So how about we repeat this exercise, but with something a bit larger, right? So we want, let's do 40, no, wait, let me think about this. Let's do 100 from 0 to 4, maybe. Okay, so notice that this one just depends on this input, right? You guys see that? So let's see what happens. Just play with it a little bit. That's a lot of data, right? A lot of data. Run that one, lot more data. Still though, the sine wave, right? So I've made it such that I got more points, but really effectively it's the same thing, right? So because it still goes from 0 to 4. So if I do 0 to 40 and I add 100, right? Let's see what happens now. I'm going to go ahead and hit run. See the data there? So now it doesn't have a sine wave behavior, right? So this could be a problem. I give you how to create this data in such a way that you get that sine. And basically the trick is it has to go up, down, up, down, up, down. Do you guys see that? And so anyway, but this is just an illustration. Let's go back to 0, 4. Like that. So what's nice about this is it shows you, given you can create sometimes like the input space and then apply it to any function to get the result of it. And then that information can be plotted basically. So here you have some kind of a relationship between inputs and outputs, which in this case is the sine function, right? Any questions on this idea, guys? No questions? All right. So anyway, this is a very common thing in the course, right? Mapping of inputs to outputs. And actually, that's what machine learning is. It's learning a function to do them, all right? Okay, so let's continue going. Did that one. Right. So there's a few functions that are available that perform basically two operations in one. So let's try one of these. So these are called aggregate operations. This is aggregate operations. Okay. So hit run. Okay, so let's add a few more cells. All right, I can be a little bit obsessive about things. Let me just do. I'm trying to work this out in my head. Ah, there it is. I knew it. All right, so yeah, so you can see there it's got more of the behavior of it. I wonder if we do this to 16. Right, so I'm just adding it by increments. Okay, nice. There we go. So there's your sign. So fun with math. All right. So anyway, so let's look at some aggregate functions. And this, as I said, are functions that have two operations in them. Let's create a vector here. X equal np dot array square brackets. And this is 1, 2, 3, 4, 5. Okay, so we have that. Now let's look at something called the np add dot reduce. So this is let's try it. Add dot reduce takes x as input. This operation obviously did something. Let's look at another one and then we'll try to figure out what they're doing. So np dot multiply reduce. That one is x. That gives me 24. So they're different. What are we reducing here? So we have 1, maybe by 5, right? So we have what? Add 5 plus 4 is 9. Plus 1 is 10. 15. 15, and then there's 5. What did it do? What do you guys think? Do you know? Huh? I don't think it takes away the 5. I think it's doing an add operation and a reduction. I think you need to run. You need to run the array one again. The array. Oh, is that what it is? 15. So 5, 9. Oh yeah. So I just added it, right? And then run the array. Okay, that would make sense. Array again. Okay, 120. So this one did what? 5. Is it multiplying them? 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. 120 times 1 is 120. Do you see that? So if this was 2, what would be the outcome then? 240? 40. You see, so you can even do these kinds of operations, more like power, but they're operations on the vectors, right? So this might make sense. One use case of it is if you have a whole bunch of results like 99, 98, 80, 55, 69, 70, and then you average all. So, you know, something along those lines. All right. So that's a good example. Oh, here we go. Okay. So we did, any questions? All right, we have other functions. Let's do NP sum. So again, I'll copy the array probably. I'm going to do NP dot sum X. And that is, it's sum them. Why is this one? Oh, yeah, because I have that 2 in there. Yeah. Or 1. So it just sums the values. So now you can perform this operation. What if you want the min and the max? So let's try that as well. This is going to be min. Okay, so that should be what? 1, 1. If we do max, it should give us 5. All right, so there's built-in functions in there so that you can process on these types of vectors. If we wanted to do an average, none of these gave us an average, right? So the average here would be what, like 3 for these values? So we don't have an average here. But sometimes intuitively, you can just think, what if I just do this? That didn't work. Mean, how about mean? That one worked. See, that's one also actually a very valuable thing because TensorFlow, PyTorch, and NumPy are all kind of trying to become similar. Sometimes you can like almost intuitively have a feeling that there's a function that does the job. Okay. All right, so we did that. So we extracted minimums and maximums. Let's do a sum over a matrix, basically. So let's grab a matrix. Okay, M2. Okay, M2, and we're gonna do sum, right, of this one. So we can try M2 dot sum. That's got a lot of values in there. 549, that seems reasonable, that it should be about 549. Okay. Let's do across an axis. So I'm going to do, let's look for a value across an axis. So I'm going to do min and max. I'm going to do NP dot min of M2 across axis 0. What do you think happened there? It's getting the minimum, right? But it's looking at all the individual columns, right? And it's picking the minimum. So if we change this to a 1, try it. The min is now what? Row wise, right? Row wise. And this could be done. Now, here's one. Try, let's see, let's take a couple of minutes. Try to do this for sum. So give me, no, sum. Yeah, sum. Give me the sum or the average on a per row basis. So you should return a vector that averages these, right? Each row. So it's a vector of 3. So what do you think you would try there intuitively? Maybe mean. Let's try the mean. M2, let's see if that works. Okay. Does that look like average row wise? Yeah. So 11, 21, 31. Yeah. That's definitely that. 51, 61, 71, 61. Yeah. Got it? Does that make sense? This is really important, right? So the example of max, for instance, I'll give you this example. What did it return? So let's do 1 here. Min of x. It gives us 1. Sometimes in machine learning, you have a machine learning algorithm that's predicting a vector of 5 values, right? It's predicting, and each one of those values will represent like a class. So that means there would be either class this one, that one, or that one, right? So what it does is it usually tries to tie a probability to that class. You see what I'm saying? So for instance, let's say that I'm just going to write a comment here, right? And let's say that I'm going to say that this is class A, class B, class C, class D, and class E, whatever it is, right? So what the machine learning algorithm is learning to do is it's learning to predict which class the item that it's looking at is more likely to be. So in this case, in a perfect world, it would do something like this. Do you guys understand? So it's always predicting a vector of 5 things, and it's going to needs to estimate this value, right? And so obviously this is a really good classifier because it's very confident with like 100% confidence that it is C. And for the other ones, it is 100% confident that the other ones are 0. Therefore, it indicates that the answer is class C. Usually, though, it won't be this good. So it'll be something like 0.10, 0.20, 0.30. Well, how much is that? 60 already, right? And then these two can be then 0.20. 0.20. You see that? So functions like min and max will do what? They'll look for the highest value. So in this case, if we do max, what should this return? 0.3. Therefore, we know that this was the highest value. Oh, and these move. So if that's the highest value, and that's the alignment of the classes, it still predicts class C. Do you guys see? Do you guys understand? So that's what the neural nets, for instance, do. You give it some input, like an image, text, whatever it is. It runs through the neural network. And if you have 5 classes, it always predicts this vector. And it really, what matters is that out of that vector, you want the one with the highest value. Obviously, this is not exactly what we want because we don't actually care about the max value. Instead, what we would want is the index of the max value, right? We want it to return, what index would it return here? 2, very good. So it starts at 0. So it really, what we want is something that 0, 1, 2. The highest value is 0.3. Therefore, we would get index 2, and index 2, then we need to know is C. This is how machine learning works a lot. And so these functions are being used for that. Later on, we'll use it. I believe the function is argmax. I don't have it in front of me right now, so this may not work, but it did work. So it's actually argmax. Argmax is the function in NumPy that instead of returning the maximum value, returns the associated index of that. And boom, we've got the class that it predicted. All right, so you can see I'm trying to, these operations tie to what we will be doing all the time because we live in the space of tensors, vectors, and matrices, and we're always going to be producing data like this. Any questions, guys? Making sense? All right, so let's keep going with the exercises. Let me actually get my charger. All right, so let's keep going. Okay, so we did min, max. We've kind of illustrated why those are important. Now we're at probably the hardest thing in NumPy and in dealing with tensors, which is called broadcasting. Okay, so today I'm not giving a full class on broadcasting. I'm only giving a very simple set of examples to illustrate sort of what it is. I need to properly give you the broadcasting definition, which you need to look for. It's not rooted in math per se, it's more rooted in just operations, right? So it's just rooted in, this is convenient to do, but broadcasting is used extensively, especially in the highly complex algorithms to be fast and also efficient. And instead of writing 50 lines of code, you write 2 lines of code. All right, so that it's a technique. All right, so let's talk about broadcasting just a little bit for now, and we will come back to this. I won't give you a broadcasting question this time around. Definitely with broadcasting, always check if you're using it, the dimensions that you're getting out, because broadcasting can, you might think it worked and it actually did something else. All right, so broadcasting is an extremely useful concept. It allows you to perform element-wise operations between matrices and vectors that don't have the same dimensions exactly. Now, this is not the same as like in linear algebra, matrix and vector operations. This is just its own thing. So we are going to look at this through examples. We're going to have a matrix and a vector, okay? Yeah, so we're going to have a matrix and a vector. So I'm going to do A equal np dot array. Yeah, broadcasting is a thing that you have to work through a lot of problems and think about things. And still, you're not going to maybe be a master of it, but at least you have a procedure of how to test it out. All right, so here is the vectors 0, 1, and 2, and then we're going to create a matrix called np dot, and we're going to make it all ones. All right, so we're going to use this construct that we used before, ones. So we just need to specify the dimensions. Oops, that's not. Parentheses. 3, 3, okay? We're going to do that. Let's print them out. So I'm going to do A, and then I'm going to do M. Okay, see, it's one is all ones, and the other one is a vector. So now I'm just going to do, notice the shapes, right, that they have. Okay, and I'm just going to, the shapes are really important here sometimes. So you want, let's actually look at that. A dot shape. Okay, 3. And I also have M dot shape. Okay, 3 by 3. All right, now I'm gonna do the following operation. MA equals M plus A. Okay, and I'm gonna print MA. What happened there? It's similar to when we had a vector and a number, right? That's kind of where it's coming from, that idea. But this is taken to the next level because now we have a matrix and a vector. And you just have to be, you're broadcasting the values. So if you think about it, we had all ones and then we had 0, 1, 2. We're adding, right? So what did it end up doing? It grabbed the 0 and it adds it to the first column here, right? So you see that? So because it's like a vector like this. So 1 plus 0, but for all rows, and that produced 1. Do you see that? Then we take 1 plus all these ones, and that produced a 2. Do you see that? And then here, 1 plus 2, but for all the rows, and that produced a 3. Do you guys see that? So another way of doing this could have been I'm going to do the following. I'm going to create B. np.array, right? Close parentheses here. B. Okay, right? That's another one. And notice what I'm going to try to do here. I'm going to do up here. Let me move this. I'm trying to illustrate what happened. So I'm going to do here 0. I'm going to do this 0 here, 0 there. And I'm going to do a 1 here, 1 here, 1 here. And then I'm going to do a 2 here. Was it a 2? 2, right? 2, 2, 2. Do you see that? And now I'm going to do M plus B. Hmm? I didn't run it. I think I did. Oh, okay, yeah. Good catch. You're right, you're right. I changed it, but I didn't run it. Right. So did it work or not? It did, right? This one, 0, 1, this matrix looks like that. And this matrix looks like that. Are they exactly the same? Yes, they are, right? So I created basically a matrix M that is this one, right? 3 by 3. And I created a matrix B that looks like that. Do you see that? And then I added them basically. They're both 3 by 3, so every cell is added together. Broadcasting is the trick where instead of having to create a matrix like this, you just say, okay, it repeats. So I'm going to take this row, broadcast it to the matrix. And it's in a way you can think of it as you take that initial vector and you just take it down multiple times. That's broadcasting. Any questions about that? Does that make sense, guys? So it's complex to wrap your brain around it, but it saves you from having to do this, because if you notice, you're just repeating that row 3 times going down. And so I just broadcast it by taking the original M and this vector, which is somewhere in here. Oh, 0, 1, 2. And I broadcast it. But But when you say I'm gonna broadcast it, it's almost like taking this one and converting it into that one. and then performing the operation. So that dimensions need to be consistent somehow. Right? It needs to be such that you would be able to broadcast. Not everything will work. So this is a tough one for sure. But hopefully this illustrates the idea. So in one scenario, we did, how can I do this? We did, in one scenario, I took that plus this one, right? Right, in one scenario. And in the other scenario, I took this plus this one, correct? Oh, no, that's the result. This doesn't look so good. See that? So this would make, the second one would make sense because it's just element wise, right? So this element and that element, this element and that element, this element and that element. That should be clear. That works. But broadcast is the trick in TensorFlow, PyTorch, or Numpy, where you would just take something like this, given this, and then it's effectively this operation here. Keep in mind, the languages do this by default, like automatically. So if it's up to you to do this correctly so that you get the outcome that you're looking for. Yes, please.
Basically, right, example where it's like 500.
Yes.
Right? So 500 of the second part, you just do that once, and then it just pretty much does.
I like your analogy because actually, when we have data, right, what are we going to have? 100,000 examples, right? And then we just have one weight vector. You're right. And so that weight vector to all of it. So you want to broadcast that one weights vector. Remember what I said, right? Input times something equal output. Input times something equal output, right? Our input is usually going to be a lot of data, many samples of data. MNIST is 60,000 images, spaghettified, so there's 784 vectors, right? But by 784 by 60,000, you just have one weight vector of size 784. So do you want to have also 60,000, or you just broadcast it and it's going to work? So you brought, that's a perfect, actually, that's a really nice question and analogy. That's, yep, exactly right. Questions? So yeah, so this is, hopefully this gives you an initial intuition. Broadcasting is a thing that I'll give you examples here and there, and we will explore it throughout the semester. And believe me, it takes time to master, and you got to be careful with it. So it can make your code very productive and very efficient and everything, but also completely unreadable. Like if you do it right, and then you leave and you pass it to you, you might have a really hard time understanding what they did, but at least you'll know, oh, this is broadcasting. And then you got to start to figure out the operations that they were done correctly. But yeah, good point. Any other questions, guys, on broadcasting? Again, we'll come back to it, and at some point I'll give you a document. There's like a definition of broadcasting. It's a set of rules of what things can be broadcasted with what other things. Okay. So we did that example. That one gave us, what did it give us? 1, 2, 3. 1, 2, 3, 1, 2, 3. All right, we're gonna do another one. Similar, but we're going to use something that we learned about on Tuesday, which is the new axis. Okay, new axis. I'll repeat everything just so I don't make a mistake. So here we're gonna need our matrix again of ones, right? So I'm gonna do another, let's say a second example, example 2 of broadcasting. Okay. So example 2 of broadcasting. Yeah. So let's do this example. It's very similar, but we're just gonna, this way I can show you what new axis is for as well. Again. All right, so we need the matrix of all ones, which was in here somewhere. Oh, this one. So we need these two actually. I'm gonna scroll down. All right, so we can create our A and our M. Run it. Okay. Print M. Ones. Print A. And in particular, print A dot shape. Okay, great. Now we are going to broadcast it, but in a different way. We want this to be applied differently. So what I'm going to do is I'm going to make A into a column vector. And we kind of explored how to do this before. You remember? Let's do A, which has some dimensions, but now we want to add a new dimension, right? So we said we can use np dot new axis, right? We saw this before. And then we just tell it that take the values as they are, but just add this new dimension. So if we did dot shape here, this has a different shape now. Notice this one was just 3. This one is now 3 rows and 1 column. So this is a column vector, right? So we changed the shape of it. I believe I have to assign it to itself. Let's do it. And then print A dot, oh yeah, sorry. No, I assigned the wrong thing here. Let's run it again. Well, actually, let's do this. No, what is this worked just a second ago, didn't it? Oh, let's do this. No. Let's do that from the beginning. Okay, yeah, I think it's just that I had replaced that variable. So now let's see this one. A. Okay, I think we're back. And then A dot shape. Yeah, 3, 1, right? This is exactly where we were before. Yeah. All right, so now we're going to perform the exact same operation. The exact same operation as before, which was what? M plus A, correct? So it should be this one. And what happened now? Things were broadcasted differently, correct? Do you guys see that the broadcasting has happened differently? Now, if you remember, in this one, it copied the 0, 1, 2 down, right? So 1 row, 1 row, 1 row. So what do you think it did now for the broadcast? It took the column vector and copied it that way, right? Before it did down, 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 down. Now it did this, this, this. Do you agree? Yeah. And you can see that because the result then looks like this one, right? So 0, 1, 2 was done like this. Zeros plus ones is 1. Ones plus ones is 2s. Ones plus 2s is 3s. So it copied it, the vector that way. Clear? Perfect. All right, yeah, that's, as I said, I'm not going to go too in depth into broadcasting. This is a big topic. This is more of a, hey, get a feel for it, and then I'll come back. Problem here and there, only practice. But at the and two things I can say about broadcasting. Number two, it's really worth it to master it for reading code and for having code that's really short and efficient. And also, it's it's just challenging. It's one of the most challenging things also. So at least you've seen the ceiling, right? At this point, this is one of the hardest things of all of it. So at least you know. Okay. All right. Yeah, so anyway, that's just an example. What else can we do? We can also do, I want to do this also. This is going to be an interesting one. I'm going to broadcast 2 vectors and produce a matrix with the 2 vectors. You see what I'm saying? So a vector like this and a vector like that, and I'm going to make a matrix. Okay, so let's do that because I think that's a nice exercise too. Let's do v1 equal np dot array 1, 1, 1, right? So we do that one. And then I'm going to do v2 np dot array 0, 1, 2. 0, 1, 2. Okay, and then just remember, we're gonna make one. They're both row vectors right now, so we want to make one a column vector so that they can be broadcasted appropriately. So here we can do that just by adding. Remember that this is a Numpy array, so then we can do the slicing here. We just say all, comma, and then np dot new access. So effectively, we're making 0, 1, 2 like this. All right. Now we have these 2 vectors, and we are going to try v1 plus v2. There you go. We made 2 vectors into 1 matrix just by using broadcast. Questions? All right, great. So hopefully that's starting to make sense. You can play with these. I think I have a few more exercises in there, do multiplications. I do have some examples in there. Some more examples of broadcasting. Right. Okay, so we're going to move on to something else. This topic is now called masking. That's also in your the links. Masking is also used, but it's actually used a lot in transformers. When you train on a transformer, you give it a sentence as an input and a sentence as an output, right? But sometimes you want to hide certain words. Does that make sense? So one example might be, we all did this when we were in high school, fill in the blank, right? We all took these quizzes, and fill in the blank, and we just like, the thing is this, and so fill in the blank. So that's one of the training scenarios, the simpler ones of transformers. What do you want a transformer to do? You want it to generate text. So where do you start? Start with fill in the blank. Give it a sentence. The cat is sleeping on the blank. right? You give that as an input here, and then up here, it should predict the cat is sleeping on the, right? And you have the actual word, but you start to hide certain terms, and that's called masking, basically. And you can do lots of operations with that. You guys see what I'm saying? So usually the mask is, if you have your data as a vector or as a matrix, you want to have an equivalent vector or matrix of the same shape that has ones and zeros. The ones indicate the things that you show, and the zeros indicate the things that you hide. Why is that really important? Can't we do that with a for loop? Yes. But in a GPU, what do you want to do? You want to perform a matrix multiplication times something, and at the same time, you want to hide some things for the algorithm to learn. So the efficient way of doing that is to have the data that fits in the GPU as a matrix, the mask that has the same dimension, because when you multiply it, the zeros make stuff invisible, and then the ones make things visible, for instance. You see that? So that's where masks come from. Again, a lot of these things, this whole class is thanks to GPUs. So if you don't like this, then, you know, change the hardware, right? Because that's really what forces us to do these kinds of things. And the example I try to give you is, if someday somebody invents a quantum computer that actually works, we may need to relearn programming again, right? And so just be aware of it. That's just how it is. It goes with that we are at the hardware level because we want to be fast and efficient. If we use all the abstractions of the CPU and everything, that's wonderful, but it's just not fast enough. And so we wouldn't be able to do these things. All right, so let's do these are simple examples of how to create masks and so on. This gets into your Boolean logic and things that you've done before. Keep in mind that in Python, basically true is 1, false is 0. So you're actually looking at the number, even though you have the word, etc., that is interpreted. So let's create, I'm going to create a matrix. I'm going to call it M1. And I'm going to just borrow one of the matrices I have up here. Yeah, like this one. Okay, so I'm going to go ahead and do this. Okay, I'm going to follow the example I have in the link, sorry. So I'm going to change these values. This is 1, 2, 3, 4. And then this is going to be 5, 6, 7, 8. And in here, I'm going to need a new one. All right, so this is going to be 9, 10, 10, 11, 12. And then the final line will just be 13, 14, 15, 16. All right. So yeah, so that looks correct to me. All right, so let's print M1. There we go. Okay, so let's try to create some masks here, just simple approaches. So I'm going to say mask 1 will be M greater than 11. No, sorry. I'm following the example, less than 5. And mask 1, we want to print it out. Do you see that? So no, oh, sorry, M1, right? M1, that's right. There we go. So here we've created a mask in the sense that, you know, basically it's a mask is just zeros and ones, something like that. And the values 1, 2, 3, and 4 are less than 5, so they are true. And then all the other ones are false, right? But in the end, if we do an important thing, which is to print the shapes, I can do the shape of M1 dot shape 4 by 4, yeah. And then the shape of mask 1 dot shape 4 by 4. Now produce the matrix based on the mask. So take the data, mask it, and give me the result. So how do we do that? If I try M1 plus or times, right? Mask 1. That's a mask. Does that make sense, guys? So the mask is the values that you want to show. So we multiply times 1, all the values in M1, and therefore we ended up with 1, 2, 3, 4. All the other ones are masked. They're not there anymore. Does this make sense? So yeah, so this is a good example of we can obviously create these when you use these masks like in language processing, you create them based on the words that you're trying to mask. Okay, and so on. So it's a very nice trick. Questions? All right, so it's 7:25. We have maybe time for a couple more of these. So we may conclude with masking today. And then what else do we have left after masking? We have something called fancy slicing. Have some math operations. Yeah, actually we almost got to the end of this. Okay. So I think yep, we almost got to the end of this. All right, so let's just finish up with masking here. So let's create a few more masks. So we can do m greater than 11. So we can just repeat this. So if m1 greater than 11, and we probably need to just in case. Right, so in this case, greater than 11 are only 13 or 12 as well, right? 12 as well. So you can see that here, 12, 13, 14, 15. Then we repeat the exercise. And now the values that are not masked are 12, 13, 14, 15. So what if I wanted all the values below the diagonal? Like I think one of the problems in the homework is about that, right? So maybe try something like this. Make sense? Okay. Let's do m equal 14. So I'm going to go here. So only one is matches that criteria. Yeah, so I think that actually they're all very repetitive. Okay, but keep in mind, one of the problems in the homework is that one of use a mask times something and give me only the values below the diagonal. You got to think about that. All right, well, that kind of concludes the NumPy review, okay? I'll stay for a few minutes. If you have any questions or any of anything, please look for the homework assignment, which is gonna be going back here, right, to matrices and vectors tomorrow. Give me a little bit of time to think about these examples. I may add 1 or 2 more. And you'll get about 5 problems to solve. So remember, practice these problems that we did Tuesday and Thursday. You don't have to submit that as homework. They're just practice, but you do have to solve the problems in that Word document, and I'll update it by tomorrow. Is that fair? All right, guys, please work on this. This homework will be due a week from today. And then next week, please have Weka install, which is we'll get into our first like data science, some data sets and algorithms. Okay, have a good weekend.